Hello, everyone. Can someone pause their mute or microphone? Okay, thanks. My name is Ryan Hogan. Um, as was just said, I'm located in Oak Ridge, Tennessee. I'm part of ARM and I'm senior applications engineer. Um, part of my job is to deliver training and provide support for the ARM HPC tools, which we'll be covering today. In particular, I'll be talking about MAP, our profiler, and performance reports. I'll run through a few examples, some by slides, and then I'll do a live example on Archer itself and show you all how to set that up. There are a few little quirks with the Archer system, mainly because it uses Cray compilers with static binaries, but I'll show you guys how to set that up. Okay, next slide. So a little bit about ARM, if you weren't familiar. ARM is the world's leading semiconductor intellectual property supplier. If you have a mobile phone, chances are it's got an ARM chip in it, or it's got ARM technology. We've kind of recently just moved into the HPC space. Well, at the end of 2016, ARM acquired Allinea to get their software tools to enable their HP systems to have a debugger and a profiler. And since then, ARM has now put out some HPC systems. And as of the last top 500, it is now based on an ARM chip, which is pretty incredible. Yeah, so just the linear history. So prior to 2016, Allinea was developing the tools, and Allinea has been at previous VI-HPS conferences. They're more well known for DDT, the debugger, but they also have the products MAP, the profiler, and performance reports, which I will be demonstrating today. Okay. Yeah. So for our tools, we not only provide the performance tools, we also provide compilers and performance libraries for our ARM architecture. But just because our name is ARM, that doesn't mean that we don't care about the other systems. So our mission is to make sure that Forge will always continue to work cross-platform. We will want to make sure that the tools will work on x86 or whatever other architecture is popular at the time for HPC. And we are committed to ensuring that the capability exists. So the nice thing about our tools is that if you learn it on one platform, it's very easy to use it on a different platform. So if you happen to be working on the x86 machine today and then happen to work on an ARM machine tomorrow, the familiarity with the tools that you learned today you'll be able to leverage that experience. Okay. Yeah, so for today's focus, we're just looking at MAP and performance reports. Okay. I'll first talk about performance reports. So performance reports is our software that's more lightweight. It's to give you a general idea of how well your application is running on the system. It's not strictly intended for code developers. People such as system administrators or support staff, they will probably tend to use this first just to get an idea of how a user's code is running on the system. The idea is that it uses a sampling-based profiler in the background, and it polls as your program runs on the system, and it figures out what kind of instructions are being run, whether it's an MPI instruction or it's a call to an MPI function, or if it's doing a vector floating point operation or an integer CPU calculation. And it gathers all of these statistics, and then at the end, it's going to give you a nice little report One way of using this tool is to tweak settings that aren't code specific. And what I mean by that is that there are some parameters like the number of MPI ranks you request or the number of OpenMP threads that you want to allow. And performance reports will be able to give you a picture of whether or not you can change those parameters to get better performance from the run. So overall, it just gives you general advice based on the statistics that it collects. So here is an example of a performance report done on an application where they noticed that a lot of time is being spent in MPI calls. And depending on your application, there may be nothing you can do about it. That's just the way the core algorithm is set up to do a whole lot of communication versus computation. So in this example here, this user was actually more concerned with the I/O, and so performance reports gives you general information on the three categories: compute, MPI, and I/O. And for each of those categories, there's a subsection in the report to give you a more detailed breakdown. So you can see here for the detailed I/O breakdown, what they were noticing is that the effective write speed was pretty poor. And it turns out for this run, they weren't running on a parallel file system. And when they switched over to running the same code, the same parameters on a much faster file system, they were able to get the speed down. They were able to speed up the performance quite considerably. Yeah, so this is one example. So it's like 41 times faster just by running on a faster file system. So this is the kind of thing if you weren't aware that you were spending a lot of time in I/O until you actually generate a report and look at the general summary. Okay. So I'm going to switch over my screen a second to how do I do that? Files, share application screen, share my entire screen. Okay, so I had previously run lamps on a NERSC machine, and this was the first performance report that was generated. You can see here that it's most of the time has been spent in compute, which is great. This is kind of what you want to see. But you can see here for the MPI section, the general advice here says that the time spent in MPI calls is low, and the code may benefit from a higher process count. So what I did was I started off with 8, and you can see quickly that I actually have 32 physical available and up to 64 logical cores, so I could have run it up to 64. But what I did instead was I increased it from 8 to 32, and then performance reports again. So now I'm not computation bound, I'm now MPI bound. So I might want to drop it down a little bit further, but I'm actually okay with this since the run is now 14 seconds compared to 26 seconds. So that's almost almost half the time. Okay, and you can also quickly see the other subsections here. So for CPU, even though this was, I could have used OpenMP threads. Like in the previous report, it says that actually for the OpenMP section, I was only using 25% of total systems cores, and I could have increased OpenMP num threads to improve performance. So this is also a suggestion that I could have tried, but I chose instead to increase the number of MPI ranks. And by doing so, when I look at the OpenMP section again, it actually says it looks good. So it doesn't even say to increase the OpenMP threads. So for this combination, it's okay. I wouldn't need to bother messing with OpenMP threads. Another section of interest is the memory. So it's telling me that I'm only using 20% of the peak node memory usage. So if as a scientist, this kind of tells me that if I wanted to run a larger problem, I can do so given the number of given the node I've requested. I have room to grow if I chose to do so. So it's just nice. Quickly at a glance, you get an idea of how much memory your code is using without having to manually track memory calls. So just at the end of the run, it'll tell you just how much memory. Like it'll give you the average and the peak. And also,
Hi, so it looked like we lost Orion there. That's the first big technical issue we've had on this workshop. So I'll see if he's reconnecting. Okay.
Okay. Hi, this is Juan from ARM as well. I will check with Ryan internally to see how the connection is.
Yeah, it said it was reconnecting and then it went away. So yeah, maybe he says he's left. He might. Yeah, maybe if you have another email channel with him. While we're just waiting.
Yeah. Okay. So Ryan just said his power turned off, and so he's waiting for the internet to come back. Sorry for this to happen. This
no, it's fine.
yeah, technical problem.
Well, we'll wait. Yeah, that's an unavoidable problem.
Okay, apologize. So please do give us 5 minutes, probably.
No, it's no problem. Just while Ryan's reconnecting, just to point out that so Ryan said, "Are we doing demos on Archer?" So the ARM Forge ARM map is available on Archer. It's not currently scheduled to be available at the start of the Archer 2 service, so it won't initially be part of it. We don't know if it will become, but it won't be there at the start of the Archer 2 service. However, we thought it was worth having it here because it's a very, very widely available and widely used tool. And so even if you are going to become an Archer 2 user, you might be able to use MAP on another system, which will give you probably useful information, especially if it's a similar type system. But we won't actually have the ARM tools available right from the start of the service, unfortunately. So it looks like Ryan's coming back online. So that was pretty quick reconnect, Ryan.
yeah, sorry about that. My power just flickered on and off. And
no, it's fine. I'm surprised you got back on so quick. It takes my internet 5 minutes to get back. I was just briefly saying that we won't actually have the ARM tools available at the start of the Archer 2 service. I don't know if we will later on, but just saying to people that it's a very widely available tool, so it's useful to them on a wide range of platforms, even if they won't be able to use it on Archer 2 at the start of service.
Oh, okay. All right. Is my screen sharing now?
Up again.
Can everyone see my screen?
No, I can see it.
I can see it.
You can see? Okay. Thank you. So what I was saying that in the performance reports is you can also see the amount of memory usage that your code is using. So what did I decide to do here? So I was happy with the performance I was getting computation-wise because it's under 14 seconds. But you'll notice that I didn't have I/O turned on. So when you're running code, you typically want to do a simulation, and then you want to be able to save your output. So what I did was in the parameter file specific to lamps is I turned on writing to the disk, so every 100 or so time steps. And as soon as I did that, I lost a little bit of performance. So it went from 14 and it jumped back to 25. Now, because I was the one who made the change, I know exactly why MPI time increased. Is because I turned on I/O, and you can see that it made a big difference. You're probably wondering why does it show up in MPI as opposed to I/O, and then that's because it has to collect all the data first before it writes it out to the disk. So that's the reason for the high MPI usage. Okay, so let me go back to my slide here. Share contents. Share files. Okay. So I noticed when I turned on I/O and in the MPI section, I noticed that most of the time is now spent in MPI, and the suggestion that Performance Reports gives is to use an MPI profiler to investigate. And that's where MAP comes in. But luckily, LAMPS itself has built-in MPI timings. And you can see from the next slide that in the LAMP output itself, the LAMPS output itself, in the MPI timing breakdown, we can see that a lot of the time is spent in output, and it corresponds to 28%. If you compare that to MAP itself, MAP gave a percentage of 29.4%. So the reason for a discrepancy between the actual timers put into the code and what MAP provides is because MAP is a sampling-based profiler, and it's polling your program every few seconds, asking the question, where am I in this code? And so it's not going to be 100% accurate, but it's enough to give you an idea of where the time is being spent. So that's why the numbers are just slightly off, but it gives you roughly the percentage of time being spent in this output routine. Yeah, so this is the advantage of using MAP, is that you don't have to manually put these timings in your code, and MAP will actually show you this just from a statistics perspective. Okay. So what's the next slide? So MAP. Okay. Yes. So performance reports, like I said, it generates a general summary of how well the application runs on the system, and MAP is more to dig deep into the source code itself, so you can pinpoint what functions are spending a lot of the time. That way, if you're looking to improve the performance, you can quickly see what lines of code might be problematic. Yes, so MAP is our cross-platform profiler. It's found on the majority of the top 500 systems, along with DDT. And it's a fully scalable, so you can either profile whether you have a single MPI or just an open MP code, just a threaded code, or if you have over 100,000 MPI ranks, you can also generate a profile on your entire program. I do want to make it clear that when you're generating a map profile, that map is not saving information for every single rank. It's actually collecting statistics, and it has to, and then it saves like the minimum, the maximum, computes the average. But due to size constraints, in order to make it scalable, it doesn't save the information on an individual rank basis. That's one of the common questions I receive delivering these map trainings is, can you give me all the information for rank 1? And well, no, not exactly, because we're storing statistical data. Okay, so yeah, so like I pointed out, it's a sampling-based profiler where it pings your application by default every few milliseconds, and it's adaptive. So depending on whether your run takes a couple seconds or takes several days, MAP will automatically adjust the sampling frequency to give you reliable information. So you can quickly identify hotspots in the code, particularly like if there's a spot where there's a spike in I/O, you can identify where that's happening. The color code. So orange stands for any type of I/O operation. Green stands for any computation operation. And blue stands for any communication operation, like an MPI call. Yes, like the adaptive sampling rate. So although it says throws data away, it's actually smartly merged together as samples, as your run increases. So you don't lose previous sample information. It's just there's an algorithm that we use to combine two samples together. Okay. All right, so this is an application where map was being done on the cloverleaf. A map profile was generated for cloverleaf, and what was noticed was that the I/O write transfer, the maximum, was actually fairly low. I know it's kind of hard to see on my screen at the moment, but so this scales from the minimum to the maximum, and I think yeah. So the maximum in this case was less than 14 megabytes per second, and it turns out that the reason for this slow write rate was because it was writing ASCII output to a file, and so map is a tool to give you an idea of what's happening, but it's still up to the programmer to figure out what to do about what you see. So in this case, one thing that can be done is to switch to using HDF5 for better I/O performance. And when you do so, it dramatically improved the I/O performance. So previously it was like 14 megabytes per second. Now we have a maximum of 75 megabytes per second, and it's done a nice quick short burst. Now that was one issue that was addressed. And another thing is that there could be room for improvement for this in MPI. So like a triangle, that typically means that MPI ranks are sitting waiting for MPI rank to finish whatever they're doing before they can move forward. Okay. So these next few slides are profiling a matrix multiplication example. It's fairly simple, where matrix A is sliced into rows, B is sliced into columns, and we're just doing a simple matrix multiply. And we started off with this unoptimized code where most of the time was spent doing the actual multiplication itself. But when you click on the line, it gives you information to the right here about this particular about the instructions computed on that line. And we can see that we're hardly using the vector unit. In fact, we're doing mostly memory accesses. And the reason for that is because we did not use good loop structure. We were striding the matrix B across J when the innermost loop was incrementing by K. So it was ineffective memory access. One solution to address this problem is to reorder the loops, and instead of multiplying by B, to multiply by the transpose of B, incrementing the K element. And just by making that small change, we can see that line of code, which took like over 50%, now is down to 2%, and it now uses vector floating point instructions. So now our main calculation hardly takes any time at all, but now we're left with a region where a whole lot of MPI is happening, and it's actually the finalize routine. You can see that MPI finalize corresponds to the blue section of the right if you were to compare it to the main thread activities. So everything on this right side is corresponding to this MPI finalize for most of the ranks. And if you use map to highlight this section, we can see the reason why. So 1.5% was actually spent this line because the single rank was doing some serial I/O. Although what stands out is the 99.5% of everything spending and finalized. What's actually more important to figure out is where the other 1.5% of time is being spent. And if you do so, you click on the function, and it'll jump to the source code, and this 1.5% is the MREC. So this is how you would have identified the serial bottleneck in this case. Yeah, so this is just explaining the source code that's responsible for this inefficient I/O, because we're just saying that only rank 0 is doing the file I/O routine. One way to address this issue is to use parallel MPI routines, and once you implement that into the matrix multiplication problem, now compared to our original code, it's now 3 times faster. Yeah, so so those were examples of using map. I think, yeah, okay. So, sorry, I'm not as familiar with this slide. So map itself is fairly simple to use. I'll show you quickly here what you would do to get it working with Archer. So let me stop sharing this and then share my screen. Again, share screen. Okay. Oh, of course, I lost my connection. Okay, so one thing I do want to mention is that when you're connecting to Archer, and if you have identity files, the best way to make our tools work with Archer is to modify your .ssh/config, and then just point to the identity file that you use to connect to Archer. The reason this is necessary is because in our client, we don't allow you to specify the identity file. Okay. So let me start up my client. So we recommend that if you're going to use either DDT or MAP on Archer, to have a local remote client. And then the way to configure that, so for this, I already have it configured for today's example, but it's just your username at Archer. And I noticed that the Forge module on Archer was version 19, but I've installed version 20.0.3 in this work TA002 shared ARM Forge directory, so you can use that. And so what I'm going to do is I'm going to create a connection in my remote client. Then input my password. Okay, so and then I can just leave this in the background until I'm ready to use it. So now in my Archer shell, let me go to, let's see. Oh, I'm not on Archer. Sorry, 1 second here. I had this all connected until I lost power. Okay, so let me go here. Because I placed it in the work directory, you'll have to manually add it to your path. So let me export both Forge, so we have access to DDT and MAP and performance reports. Okay, and let me get, I did. So okay. So by default, when you're doing any type of profiling, whether you're using MAP or performance reports, you're going to have to link in a wrapper. And the best way to do that is so let me just manually do this for you. So is to create a directory. I'm just going to call it wrapper. And in my path, I have make profiler libraries. So I'll show you profiler libraries. So this is a tool that comes with both performance reports and Forge. And the way you're going to use this on Archer is to call it, and then you're going to pass it the argument libtype equals static. So normally on other machines, they make dynamic binaries so that all of our profiler libraries can be linked in at runtime. But because Archer creates a static binary by default, at least for me it does, I have to, ahead of time, make the sampling libraries and link it at compile time. So I'm going to generate create static libraries in this directory. And as soon as I issue this command, it's going to give me instructions on how to link it against my application on Archer. And I'll just go through this process and show you that. So this will be necessary, again, for both performance reports and for MAP. Okay, so it says add this to your link line. So I'm just going to copy it and then modify my makefile to use this. All right, so I already had one previously, but I'm just going to use the one that I just created. Okay. And once it's done, I can just make it. Oh, I already built it, so make clean. Yeah, you're going to get this warning, and that's just saying be careful using this in a statically linked application, but it'll be fine if you use it. Okay, so let me get an interactive job here. History. It's not here. Okay. So luckily I have the documents pulled up. Interactive. Okay. So I just need one node, and I'm just going to use it for 10 minutes on TA002, and what was it? Q short.
No, Ryan, there's actually a reserved queue. So if you actually, I would Control C that actually.
Sure. Yeah. Go ahead.
Yeah. So if you do the same thing but use the queue instead of short, it's R, capital R, 7133 971.
Okay.
And you can ask for as long as you like in that. You can do more than 10 minutes because it's not restricted to that. Yeah.
Okay.
It may take a while to start. It's just because PBS is very slow, and as soon as PBS knows as soon as it notices your job, it schedules it, but it takes a while to notice it.
Okay. Let me go back to where I was here. So I have it here. So is my path saved? Yes. Okay. So I don't have to export that. Okay. Sorry, it's slow. So to generate well, first we'll do a performance report. So we can say perf report AP run -n12 /slow_f. So the idea when using our tools is you take your natural line, that your natural MPI launching line, and just stick our tools in front of it. This is what we call express launch. And it doesn't work with all MPI implementations, but for Archer it does work. So it's going to be natural to just either use DDT, MAP, or perf report in front of your AP run command. So this will run for about 30 seconds. And when it's done, it's going to generate two different files. It's going to generate a text file and an HTML file. I mean, I've already shown what the HTML files look like. So at the, for this one, I'll just open up the text file. So if I just open that up in less, probably easier to just highlight it. Okay, so this is kind of what you would see in an HTML file, but in text format. Nice little graphical bars here. It's telling us that this application was MPI bound. A lot of communication versus computation. It took 29 seconds. It remembers what the command I was using to call performance reports. It tells me information about the node itself, like how many cores are available, how much memory is available, and when I ran it. So this is kind of useful if you wanted to collect performance over time, kind of like doing regression testing to make sure that nothing is broken. You can generate a series of text reports and then just look at them manually, or you can create your own parsing tool if you want to get fancy. But yeah, you can see the same type of information. We've got our main section in the summary, and then we have our subsections for CPU, MPI, I/O, and memory. So in this case, it's telling us that there might be a load imbalance from synchronization overhead to use an MPI profiler to investigate. In which case, we'll pull up MAP to look at it. But for general summary information, this is where performance reports is useful. It's also telling us that we've only used 9% of the total memory available. We can increase the problem size if we need to. And it may be more efficient to run with fewer MPI processes and more data on each process. So that's kind of just like general advice based on what performance reports sees. Okay, so that was the report. So let's switch on over to generating the MAP profile. So it's the same idea, only instead of perf report, we do MAP. And this can be done in two ways. If you're sitting in front of your terminal and you have it connected with your remote client, you can do map-connect, and that's typically how you would use DDT, right? You would just say DDT-connect on your application. But say, for instance, that you have this in a submission script and you don't know when it's going to go through a queue, you can generate a profile now and look at it later. So you can just say map-profile AP run on your executable. And for this workshop, I provided temporary licenses so that you can use both MAP and performance reports. And you can see that's going to expire Saturday, August 1st. But until then, you're free to use the tools on Archer. Archer itself does have access to DDT and MAP for a higher processor count. So if you have a traditional Archer account, you're also able to use that. Okay, so it generates this nice MAP profile. You can see in terms of size, it's under 500K, it's just 300, slightly over 300K. And to look at it, so I don't have to be connected to an interactive job. I could do this on the login node, but Well, one way to do it is to just do map-connect on the file itself. And what that will do is it will send a notification to my remote client to do a reverse connect request. And then I just say accept. And the nice thing about using the remote client in reverse connect is that all of the graphical traffic that normally would happen if you were doing X11 forwarding now have all of the graphical updates happen locally, so you have a much smoother GUI experience. Right, so now we see our profile. We see the source code, and we also see by default all of the functions on the main thread stack. Quickly, we can tell that most of the time is being spent in this imbalance function, and the other majority of the time is spent in this section here under overlap mostly. And you can navigate it two ways. You can navigate it through the source code. So for instance, I want to know what this imbalance, I want more information about this imbalance function. So I can right click imbalance and say, take me to the source for imbalance. And in doing so, it'll break it down for the function or subroutine imbalance. Show me line by line. Actually, for the total of 55.9% in this, 29.3 was on this line and 26.6 was on this line. So one is doing a square root operation and the other is calling MPI all reduce. So you saw me do it through the source code. I mean, similarly, I could have just expanded the functions to get that same information. So I'm interested in the first region. I just expand that. I can see the two lines. So one is the MPI all reduce, and notice as I click on the function, the source code automatically updates. Oh, well, it shows me the line of source code is what I mean by that. That corresponds to this timing. Okay, so that's navigating the functions on the stack and the source code. But yeah, this is the general view. And the way to interpret this is from left to right, that is when the program starts to when the program finishes. And as I mentioned earlier, green is where we're doing a lot of computation. Blue is communication, and orange would be I/O, but there isn't any for this example. By default, you see the memory usage, and you can see that it's not until this point in the code that we actually do a major allocation. So we can actually identify the lines of source responsible for that just by saying I'm only interested in looking at source code that corresponds to this region. Okay, and so most of the time, actually, so it's actually a combination of both MPI imbalance and stride. But if we go to stride, we don't see allocation information here because it's not in green or in blue, but this is where it would have happened. So as a program, you would kind of want to, I guess, first identify from the marker, you know, what came after that. So in this case, it was actually computing this computation here. Okay, but yeah, so let me stop looking at that. So this was the main preset. We can also look at other presets such as CPU time, if that's of interest. So you may be running an application and then somebody else may be running on the same machine. It's unlikely, but this will actually show you in the system load if it's become overloaded at any point. Typically, when people look at map files, they're mainly interested in the CPU instructions, the memory, and the MPI. So CPU instructions, so this will identify any areas where the floating point is either being used effectively or not being used effectively, or if it's doing a lot of branching. So you can see throughout this code that okay, let me take that back. As you move your mouse in the region, you get an instantaneous snapshot, and at the bottom here, the statistics for that instance in time gets updated. So you can see which rank had the highest vectorization usage. So in this case, it was rank 7 had 100%, but rank 4 only had 0%. So that might be useful to identify what's happening there. Yeah, and okay, yeah. Also, you can use the tool to identify regions. So in this case, we're seeing an increasing number of MPI. So the idea is to figure out, is there an MPI bottleneck here? So the source code that corresponds to that is just calling this MPI all reduce, and it's not clear right away why there's an MPI bottleneck, but it's up to the programmer to kind of dig deep into the code and try and ask themselves the question, why is this the case? And for this particular example, it has to do with the fact that we're looping from j equals 0 to PE, which just happens to correspond to rank. So depending on what rank you are, you're doing more work, and that's why you kind of see a load imbalance. It's not clear from the code itself, but it's clear that there is an issue, and it's up to the programmer to identify what's happening here. Okay. All right, and like I said, memory, like we've already seen that, and MPI, just in case there are other MPI bottlenecks. Yeah, so generating map files is pretty straightforward. The tool itself isn't going to make your code faster. It's still going to be up to you as a programmer to be able to interpret what you see and identify if there are issues, and then come up with answers to address those issues. Okay, so that's generating the map profile. So let me close that out. One thing I do want to say is, so sometimes it gets stuck here in your client. You just got to go back to get your shell back. Is that these map profiles? So once you generate it, you can share it with your colleagues, and they don't need a map license to look at the map profile. So you can discuss, hey, I noticed that there's a bottleneck here. There's a lot of I/O happening in this region, or why is so much time being spent in this? And you can have discussions with your colleagues to work through the code. Okay, let me go back and Oops, right here. Stop sharing and go back to sharing the content. Okay. Yeah. So these are kind of things that you can do with map. You can look to see if you have a memory leak, if the memory is growing. If it's growing on a single rank, you'll just see one line. If it's growing across all the ranks, well, I mean, if it's going across all one rank, you'll see one of them growing, and then you'll see a line for the rest of them being really low, and you can quickly spot out that there's an issue there. Or if they all collapse onto a single line, then they're all using up more memory. You can use it to spot MPI imbalances. Like if there's more blue than you think is happening, then you probably have an MPI load imbalance. Sorry, I forgot to mention, when you're looking at that, as you go up and down, those correspond to the number of MPI ranks. So in this case, it's saying that over 50% of the MPI ranks are in an MPI. Another way you could use map is to identify whether or not OpenMP regions make sense. So if you have an OpenMP code and you notice a lot of this gray, so this gray stands for OpenMP synchronization, it may not make sense to turn it on for a certain loop if you're actually spending more time synchronizing the threads than you are doing OpenMP calculations. And then I've shown an example of if there are memory access issues. Like if we see in the metrics that there's a lot of memory accesses, we might need to restructure it in order to get better vectorization. Okay. Yeah, so I was just mentioning that, just map is a sampling-based structure here. Yeah, and it just gives you like the compute, the MPI, and the I/O. Yeah, that's. Yeah, so these are the things that kind of look out for. You want to identify whether or not you have a hotspot. So if something peaks, that'll stand out for you. You might want to pay more attention to that, whether it's a hotspot in I/O, whether it's orange, or it's hotspot in communication. So sometimes you might have what's called a flat profile, where there's a lot of time being spent, but it's being spent evenly everywhere. And in which case, there's no one single function to focus on. You have to focus on the whole code. And that's just there's not much you can do about that if you have a flat profile. And so I didn't mention previously and what you need to do. So if you want to be able to navigate the source code, you would typically recompile your code -G just to get the debug symbols. I mean, you certainly can profile a code. If you don't do this, you just won't see the exact source code information, but you'll still get general function function timings. And we recommend that you use your normal optimization flags when you're profiling with map. Yeah, so I'd shown how to do this in the example. Yeah, typically we would say we would do that with MPI run, but for Archer specifically, because it's a Cray machine, you would use AP run to launch your application onto the Kubernetes. Okay. A new feature that was introduced in our tool is Python profiling. I'll be honest, I haven't tested this on Archer, so there may be some hiccups, but we're here to help you through that in case there are some issues. But the idea is that you can profile Python code the same way you would profile your typical MPI application. You just stick map -- profile in front of it along with Python. Here we're profiling a simple Laplace solver, where it's just computing U's based off of the information around it. In Python, it's not very efficient, and when you create the profile, you'll see that a lot of time is being spent in the Python interpreter itself, which you kind of want to avoid because that's fairly slow. But if you were to say use NumPy, which is always highly recommended if you're doing any type of C Python work, is to use NumPy. And if you switch over to using that and then profile it, you notice now that we're not spending a lot of time in interpreter. We're spending more time in compiled functions, and then that's kind of what you want to see. Is you want to see a lot of green, so that the CPU is being used. So this run was actually doing 10 times more iterations than the previous one, and it took about the same amount of time. So like you see at the top here, it was like 22 seconds. The previous example, I think, took 27.7 seconds, but it only ran on 100 elements. So just by using NumPy instead of pure Python, we've got a speed up. Yeah, so that's just to show you that map can be used on Python code, and you would apply the same principles when looking for timing information in your Python script. You would look at to see what percentage of time is being spent on what line in the Python script. Again, it would be up to you as the programmer to see if there's anything that can be done about it. Okay, so I think that is it for the slides. So I haven't been in the chat, so let's see. Questions. Were there any questions? Okay, I see that. Yeah, go ahead.
I was going to say there's one about the how to access the local client.
Okay, so that will be available on our website. Let me. Can I? Actually, let me just copy and paste it real quick here. Now, Archer is unique in that it's running SLUS 11, which is an older version of the operating system, so it doesn't support our latest Forge 20.1, which is a little bit of a shame because 20.1 introduced Python debugging with breakpoint support, but the other features are still available. So let me send you a link to the older versions here. Okay. Copy. And let me paste it in the chat to everyone. Okay. There is where you would download the Forge client for whether you're using Mac, Windows, or Linux. And you would want, so if you want to use the tools that are installed for the workshop that I used, it's version 20.0. But if you're going to use the one that's currently installed on Archer, you would want to use version 19. Okay. So unfortunately, that's all the examples that I do have prepared for today. So Rudy, if you're on the line, do you have any that you can share with users at this moment?
Yeah, what time did we say we're having a break? Because you can always go over this optimization example I have first, and then maybe later we can go through the other examples in a bit of a hands-on. It's up to you, really. If we should do my piece first, and then at the end, just get everyone to play with Forge.
Yeah, if you can just demonstrate a few things before 10:30.
Yeah, so it's 3:30 UK time.
Yeah, I'm sorry. 3:30 UK time. Yeah.
Okay, yeah, I mean, I can get on with that. I need to share my screen, though.
Okay. Oh, I guess could someone make Rudy a moderator if he's not already?
I think Rudy should now be the presenter.
Okay, can you all see my screen? Okay. I should have a Linux machine up with 2 map profiles.
You'll have to click share content if you haven't already.
Okay.
You have to click share content and then share application screen, and you can choose whether to share your whole screen or just a window.
There we go. Found it. Okay. What do I want to share? There we go. I've got it. Yep. Can you guys see my screen now?
Yep.
Okay, cool. Yeah, so to be honest, I'm not that familiar with Archer, but I'm quite familiar with the ARM tools and map, etc. So when I actually first went onto Archer, I was playing around with the BT-MZC example and just running it out of the box. I noticed 2 things. So the first one was when we're running the GNU example, it runs within 21 seconds. And when we run with the Intel compiler, it takes 74.3 seconds to run. So there's obviously a problem. And with me not being that familiar with Archer, it's kind of try to use map to see if we can actually drill down and find out, if we can at least find some kind of issue, and then see if we can resolve that. So if you look at these 2 profiles, so this one here, running in 21 seconds, this is the GNU profile. You can see that the first thing that's very obvious is there's a lot of gray in the Intel compiler. And this gray is the OpenMP overhead. So compare this to the GNU compiler, there's just a lot more overhead. And well, at this point, we don't really know why. But the things that we do know is that the overhead is 80.1 OpenMP overhead, and this one here is about 20%. And this OpenMP overhead there is everything in all regions, whereas if you look at this OpenMP regions here at the bottom, this will give an overhead as well, but this is OpenMP overhead in those regions. So this is kind of giving all the OpenMP overhead this time glimpse there, whereas this one is just in the regions themselves. So the question is, how can we deduce and kind of drill down into map and see what the problem is? So there is an obvious problem, and we want to kind of figure out why. So the first thing we can do is we can have a look at what the compute is actually busy doing. So if we look at MP regions, we look at this Z-solve over here, and we can see it's spending 8.8% of the time computing that Z-solve. But this is actually 8.8% of this 74.3 seconds. So that's 6.5 seconds it's spending in Z-solve computing this. And then if we move on to here, we can compare with the GNU compiler. So Z-solve is 22.3%, but of 21 seconds, that's taking 4.6 seconds. So in comparison, actually the compute time is not too bad. Intel compiler is taking about 2 seconds more to solve the Z problem. And you can see there that it's spending 4.7%, 4.4% in X and Y, which is roughly half the time before. So it's actually Intel compiler is doing a bit better with the X and Y solve. So the compute actually seems fine given this. So the thing that you could probably say is what is Archer actually doing? So I just did a module environment swap. So pretty much just loaded the GNU environment and the Intel environment. So one thing that could have happened is maybe the Intel MPI got loaded, and it's not very easy to see in Archer what actually gets loaded. But with MAP, at least you can click on this, and you can say with the GNU compiler, we're running 8 processors, 2 nodes, 6 OMP threads, and the MPI implementation is this Cray X series MPI. And if we compare this to the Intel compiler, it's the same thing. So 8 processors, 2 nodes, 6 OMP threads, and implementation is Cray X series. So everything's exactly the same between this Intel run and the GNU run. The only difference is the compiler. So what we can do is we can dig a little bit deeper into this. And if you look at some of these metrics, we can look at things like the CPU memory access. If I can find it, this one there. And here you can see that the CPU memory access is quite high, higher than I would have expected. The system load. Oh, I'll do CPU time first. So the CPU time is quite an interesting one. But if you want to know exactly what all of these means, ARM's got some documentation. So if you look at CPU time, and you can search for all of these on the ARM documentation. It says this is the percentage of time that each thread of your program was able to spend on a core. It's usually a key indication of something that's oversubscribed. So that's a good hint. The CPU time 16.6%, which indicates possibly something's being oversubscribed here. And if we look at some of these metrics, and we can look at the system load, and this is another interesting metrics, because this is kind of saying that these cores aren't actually being utilized very efficiently. Some of these threads are just remaining idle, not really doing anything. I'd expect the system load to be a little bit higher, and even this CPU floating point. I mean, all of this kind of sees that this application is possibly not really running very efficiently. So the second thing you can kind of look at is, well, what's the MPI busy doing? Is the MPI maybe a bit slow, or something's not quite right there? So if you look at some of this MPI stuff, first thing I want to look is the send, and you can see it's 5.9 megabytes per second, which is, it's not very slow. Maybe we can compare this against the GNU MPI calls. So if we look at send, So this is actually the Intel MPI is faster. So the Intel compiler is faster than what the GNU compiler is saying. So it's not anything to do with the bandwidth, perhaps, or some slowness in the MPI. So that's another hint. And then we can drill down and we can say, okay, well, what's the call duration busy doing? And yeah, I think is the biggest hint, along with everything else. It's kind of like you need all these views all together to kind of come up with a hypothesis. And you can see all these spikes here. So this MPI call duration is a spike. There's loads of spikes. And it doesn't seem like the MPI is very balanced. And we can drill into this, look into that spike. We can click on functions. And what's busy happening here is it's hitting MPI wait all. So kind of like these MPI processes are just waiting for the other MPI calls to finish. And if you look at all of these spikes, they all are MPI wait. Yeah. And if you compare this to the GNU example, so if we view metrics, MPI call duration. So you can see, yeah, there's only one big spike in the start. And what the spike is saying here, if you go to functions, is it's MPI setup time. So that's fine. It's what you expect at the start of a program. But everything else you can see is quite well balanced. And there are no MPI wait. So what this really does indicate is that there is some imbalance, and the imbalance is very likely to do with some of the binding. So the way that something's running on the machine. So not necessarily the application. So you're running the same application exactly the same way. The only two different things is GNU versus Intel, and one of them isn't running efficiently, the other one is. So the only inkling that there's, well, the most likely cause to this is some of the bindings just aren't right. So actually from this, what I've done is I've done some research, looked at Archer, and actually what Archer is busy saying. So there were a few avenues I went down. So I set this KMP affinity flag, but I set this to verbose and had to play with it to see what all the different threads were busy doing on all the different cores. And there was definitely some imbalance there, so they weren't set up. But actually, this line of code actually solves pretty much what's going on. So on Archer, it advises, if you're using the Intel compiler, set the KMP affinity equals to disable. And when you run the AP run, I've set it to run with CC equals NUMA nodes. Let me just go into Archer. So this is what my PBS script looks like. This is our run map. There's actually some dynamic linking I had to do as well. I'm not sure if Ryan actually explained that, but I could go over it in a bit. So I changed from the Cray program environment to Intel, and I set the KP affinity equals verbose. So I've tried a few things actually. So I tried to do the OMP proc equals spread or KMP affinity equals balanced verbose, but none of them work. The only one that works is what the Archer was saying, was to disable it. But the problem is when you disable it, you can't actually use the verbose it's busy doing in the background. But I've set the CC equals NUMA nodes as well. And this, I can show a profile when I set those. Okay, so this is the GNU compiler. If I close this profile, and now if I load the profile with all of those set, yeah, you can see it's a lot better profile. It's now running in 17.6 seconds, and this is a big problem. So sometimes you have code and it's busy running really well on one machine. You kind of port this over to another machine, and some hardware restraints on that machine just means your code is running much slower, and it's kind of difficult to actually work out where it's going wrong. So the map kind of indicates you into that direction, and just reading up on what the machine actually wants, you can actually fix your code up. So let me just put these two together, and now we can look at the CPU floating points. That's already up there, so it's 45.6%. So it's doing much better. Let me just close this memory one because that's not that important. CPU time. Yeah, so what's interesting here is actually the CPU time has gone from something that's not been very good, not been utilized very well, to be overutilized. So maybe there is some optimizations, or maybe using some more MPI calls to actually make the code run to be a little bit less on the CPU time. Let's look at the MPI sent. Yeah, it's the call duration. So here we go. So the first spike, as we know, is just the MPI setup, which we would expect, but there's none of these MPI wait calls anymore, and the overhead has been reduced. There's still some overhead, and there's probably things that needs to be done. Maybe running more efficiently, maybe with less OMP threads and more cores, perhaps, which will reduce this overhead. But it needs some more digging into it to actually work out. But it's running as I would expect, so pretty much the same as GNU. Cool. So that's pretty much all I wanted to do a demo, because I had a bit of trouble with Archer. As I said, I don't understand it very well, but kind of used MAP just to understand a little bit more about the unloading and then reading up to kind of fix that problem.
Can you look at the context switches in your original Intel experiment?
Yeah. There we go. Do you want me to compare it with the changed one?
Yeah.
Yeah.
So you have a lot of context switches in the original.
Yeah, there's a lot of context switches in the original, not so much when we made those changes.
In my experience, the Intel compilers create an extra thread, which I don't know what it's used for, but there's an extra thread, and that kind of gets in the way when you're binding threads to cores. So if you bind 6 OpenMP threads to 6 cores, but you have this extra one from the Intel compiler, that starts interfering.
Yeah, there's quite a lot to understand about how you bind things with the Intel and the extra threads that get created. But as I said, like, I'm very much kind of ARM based, so don't know really much about Intel. But yeah, it kind of makes sense. Yeah, is there any more questions? I think it's a break now.
I have a quick question. So everything has been MPI or mixed MPI OpenMP. Do you support pure MPI, pure OpenMP programs as well?
Yeah, I think so. I mean, Ryan, can you?
Yeah, we do. There may be some work to launch it on the computer with AP run, but in practicality, yes, we do support OpenMP, just pure OpenMP.
Thanks. So if there are no more questions, I think we have a break till 4 o'clock BST, 5 o'clock European time. And thank you very much for the presentation.
Cool.
Okay, so I think the schedule for this next session is hands-on exercises using our map. So I think, Ryan, are you going to take over for this session? Or present the session, rather?
No, Rudy will be doing this one.
Oh, sorry, okay. I'll make them presenter. Okay, Rudy, I think you should be able to share your screen again.
Okay, thanks. I think I've got that. Yeah, so let me get rid of that. So as you were saying, that this is just a hands-on kind of getting to know how to use map and performance reports. But the thing is, we should probably talk about dynamic linking. When we run an application with map, you have to dynamically link your programs, or map won't be able to actually profile anything. So we go on to just show I've done this. And we do make def. Yeah, so the first time I tried to compile this, it was complaining with this argument here. So I added that in. And the way you can dynamically link, actually, map has a program you can run, and this automatically does it for you. So if you load your MPI compiler, what do I have? Module avail. Actually, I don't think it matters. I think, yeah, so Archer, it's Intel compiler, so that's fine. So if we go into this ARM directory and you run bin, move that out the way. Then there's this application called Make Profiler Libraries, and if you just run that with to run Make Profile Libraries, map will create this for you. And what it does, it provides this dynamically linked command line argument. So you can just copy and paste this. So I'll copy this, and you can see it's built it now. CD. Yeah, so you have to just copy that link into this F-link flags. Where it says it dynamically links it and gives the path to where these libraries are. and it gives some of these map arguments you'll need. And it says the R paths as well. So this is when you actually run your application. It's just a map knows where to find them as your application is busy running on the compute nodes. Yeah, and if you copy and paste that in there, then you should be able to build. So I've already built this. We just run make. Yeah, and then when I ran map and collected those profiles, then it should all just work. You should be able to get your profile out. If you complains about anything, just let me know, and I'll try to sort it out. But we actually have these examples. Is it work? TA002 shared arm. Yeah, so within here we have these HPC examples, and they kind of just basic HPC things like seeing imbalanceness and I/O, etc. And they all come with some user guides of how you use them and how you can connect them up with them, and then there's some pointers of how you can fix the code to optimize a little bit better. So I think for this session, probably just use map. It's best to use the remote client and connect Archie with that, and just run these examples, see what map gives, profile them, or you can bring your own HPC code. And I think me and Ryan will just be around to help out with any questions, or if you run into any linking issues, or if you just run with any issues with the tool itself, then we'll try to help out. Does that sound fair?
Yeah, I think so.
Hi, this is David at the ARM. I just wanted to run a quick profile of a code of mine, a quick overview using Forge, but I'm afraid I had to drop out the session. I'm really, because I had another meeting which came up at a short notice. Which slides should I look at, just as a kind of prescription of how to get my code? Just you point me at the right. I don't see the slides on the website. Maybe that's my. Oh, sorry. No. Okay. I just.
Yeah, so I don't have the instructions on the slides themselves. I did paste
All
it
right.
in the chat.
Sorry, I apologize. I had to. There was a admin meeting I had to go to, unfortunately. So they were. Okay. Fine. I've got fine. Okay. I was on the wrong chat. I was looking at the wrong chat window. I was looking at the moderator chat window. That's why I didn't see it. Excellent. Okay. I've got it. Thanks. So that will work. Just okay. Fine. And for the Cray, do you have a preferred compiler that you think is best for the ARM tool works best with, the GNU, Intel, Cray, or do you get fairly neutral?
Yeah, we're neutral on that front.
Okay.
Unless you're on an ARM system, then we'll recommend the ARM compiler.
Fine.
So
we have an ARM system here, Catalyst system. Is that the right word? I'm never very good with names, but so I got a linking. Oh, got a load error.
Is it possible for you to share your screen?
Maybe try with a different compiler actually. The problem is I can't use, for annoying reasons, I can't use the GNU compiler because of I'll just check if it works. Oh, I think I know what I might have done actually. I may have created the libraries with a different compiler from which I compiled with. Do you know what I mean? I think I may have created done a make profile library with a different compiler from the one I then compiled my application with. I did the module swap too late. That could be the issue.
If you're using something other than Cray, then you're going to have to pass in another option to make profiler libraries. You say -- platform equals default. Because our tools detect you're on a Cray system, and we're going to assume that you're using Cray compilers. But if that's not the case, you're going to have to change that.
I'm using the compiler wrappers, but maybe not. I don't know if that's what you mean, or let's do okay. I'll do the Cray ones though. I've got myself. The one thing I don't like about modules is they're invisible, so you don't know. Yeah, you've got a make file and you've got a executable, but you don't know which compiler you used because it was, at least on the Cray, you always call the compiler CC or FN, so it can get yourself in a twist. Well, I do anyway.
So I have a pure OpenMP code which I was trying to run with MAP, and it appears to have only profiled the program AP run and not my program. So I assume I've made a mistake in launching it.
Well, I think, does it normally run without map on the compute node?
Yeah, the program itself runs without map, and so I've used it with MPI programs, and it works fantastically well.
Okay, so you may need to use an alternate launching method. So can you paste into chat the command that you would normally run without map?
Yeah.
It's slightly weird on the Cray because even for OpenMP job, you have to run it through the MPI. You MPI run a single process, so it is slightly strange actually. You don't just normally you just run the executable, but even the pure OpenMP you have to go through the app run, which is a bit weird. But,
so srcdir is just set to the location where my program is, and then after that you're just telling it to load a particular input file.
and the -d and the -cc are just placement options, aren't they?
Yeah. And then
What's CC
N1.
done?
Sorry?
Oh, that's no affinity, is it?
I think so. And then you can also use NUMA_node as the other option.
Oh, idiot. Sorry.
And this is built with the Intel compiler.
Sorry, I'm calling myself an idiot, not you, Paul. Sorry.
Don't worry.
I didn't export the path to the ARM tools in my batch script standard. Oh.
Can you see if this command works for you? So what we're doing is we're telling map to use compatibility mode, and we're explicitly passing in the MPI arguments.
Yeah. Well, I think
so.
David, I'll still need an AP run in there somewhere to launch it on a compute node, correct?
I can't find perf report. I've done something. Do I need to module? What do I need to? I haven't loaded the right module, have I?
So you'll have to add it to your path. It's under work shared ARM reports bin. It's another export statement that I had out there.
Oh, sorry. Okay, I thought they were the.
Yeah, so prior to the previous version.
I thought you just. I thought that was the same thing touched twice, but I didn't read it carefully enough. Right, that's got it now. The performance report literally comes out as a PDF, does it? Or
no, it generates both an HTML and a text file.
Okay. and I need to I can run map on Archer, although it might be better to install a local client. Is that what you're saying? If I do to analyze I do map minus profile.
So the
map
dash dash connect, that's if you have a local client on your machine and you've already connected to Archer. Now, if you're doing X11 forwarding, you can just do map to and then pass it in the map file.
Okay, fine, right, okay. I'm just doing I'm doing a performance report just to start with.
Paul, did that command work for you, or is it still not working?
Sorry, this was a program I built a while ago, and I think I might have mixed up some program environment. So bear with me. Thanks.
So one of the projects me and Paul work on is Asimov, which is joint with Rolls-Royce, looking at optimizing their simulation software. And some of the issues are that their real software is commercially sensitive. So we're developing a few sort of standalone benchmarks which are representative. That's what I'm running a linear solver, and Paul's code there is sort of simulating the way they do their finite volume. You're simulating one of their calculation codes, aren't you, Paul? Or at least trying to. Yeah, finite. But we have run map on their full codes, but that's quite heavy. But they take hours to run, so it's nicer to have little little benchmarks you can play around with. So what's the charging model for map for the tools? Are they on a per core? As I said, it's unfortunate we don't that they don't. We're not initially going to have the ARM tools on Archer 2. That would be we'd need to get money from EPSRC. They'd need to, I guess they'd need to give us money to buy it. Do you know what the licensing model is? Is it per core, or is it sort of on a use basis? Or
it's per MPI ranks. So you get like a pool of tokens that you check out. Every time one MPI rank is used, you use one token.
okay.
The number of threads is unlimited, but it's capped by the number of total MPI ranks used at any one time.
Okay, and that's not a function of the machine. You buy a license for, so we could buy a license for 1,000 MPI ranks or something, and that would give us.
Yes.
Okay, and that's a simultaneous. That's sort of simultaneous. That's like checking out a certain number of versions of software, isn't it? That's at any one point you can be running map on 1,000 MPI ranks, is what you're saying.
Yeah, and if one person is using all 1,000, then no one else can use any.
Yeah, no, I appreciate that. Okay, yeah. But at least it. Fine. So when do I get the HTML file? I don't know if I don't seem to have it yet. Oh.
Should generate it at the end after you do perf report.
Oh. I did perf report AP run. But I can't see anything. Is it just in the directory or is it a subdirect? No, just in the.
It should be in the root directory that you ran it in.
So I'll share my. Can I share my screen? Is that okay? So did. Oh, I was an idiot. Sorry. No, I understand what I did. So I didn't add the correct link line into the I added it into the Intel build script, but then I switched to Cray. So that's my problem. I understand what I've done, so I'll stop sharing.
Okay.
To ask about the memory use. Sorry, I don't know if is my audio. Have I messed up?
No, we can hear you. I'm sorry. What was your question?
Oh, sorry. I think you covered this, but again, can you track memory use per node rather than per rank? Because that's often the actual limit on the physical limit on a is the per node memory.
So performance reports will tell you the peak node memory usage and the average.
Oh, we'll give you that. Okay.
Yes.
Right. Actually, I'm going to get one because I have a very my test application is quite badly written and it does a lot of serial stuff at setup. So actually, rank 0 can use huge amounts of memory and other people don't use much. So I often run out of memory on a node, although the average memory usage is quite low. It's quite. I've never been quite sure. It'd be nice to know what that tops out at actually, because I have my. So do you share any of the sort of visualization technology with DDT? Yeah, or is it totally separate? Is any of the code base shared, or is it?
I'm not sure what you're asking there.
No, I think they're
Just I
completely.
know
So a GDT is a debugger, and MAP is more of a profiler, so they kind of do separate things. And
right.
I think that there's maybe one part that's the same, but they're mainly different. They don't share that much code.
Right. So I didn't get. So I'll share my screen again because I think I did it right this time. So I did. The make file I did. That's all I need to do, isn't it?
Yeah.
Fine. And then I did this, which is just perf report AP run instead of AP run. Oh, I think I know what the issue is. Do you hook into had this yesterday with running 7157. Wait, I don't get any. Oh, Oh, I tried to run too many processes. Okay, fine. Sorry, what's the limit? Sorry, that was my stupidity.
Oh, I have it capped at 128. But I can increase
No, it's fine.
it if you need.
No, it's fine. It's fine. I'll do 120 is fine. That's 5 nodes, isn't it? I should have read the output more carefully.
Hi, Ryan. So I get -d is not recognized. Do I need to put an AP run in after the MPI args in your command?
No. Give me a moment to try and sort this out. So what should have happened is that MAP should have detected that it was trying to launch an MPI code, and it would have called AP run for you. Yeah, so this is one of those tricky things because you're running an OpenMP code with an MPI launcher, but it's not an MPI code.
Exactly.
Yeah.
I do actually have access to an ARM system which has ARM map as well, so I might try it on there. The only problem is how to actually view it from that, because if I download a map profile from another system to my local computer, can I read that directly?
So the MPI wrapper was not preloaded.
Yeah, you're able to look at it, but of course you'll have to provide the path to the source if you want to see the source overlaid with the profile, if you're not on the same system.
Yeah.
So so David, that was trying to tell you that it wasn't compiled and linked against the profiling members? Yeah, you might have to relink it.
I am doing that. I think it might be. Do you intercept MPI init? Is that one of the things you do?
We set a breakpoint at MPI init. Okay, so we intercept all MPI calls to get the profiler working. That way we can know how much time is spent in each MPI routine.
Sorry, Ryan, I hadn't modified my launch line correctly. I'll let you know how this next run goes.
Okay.
Ryan, are you still on the line? Sorry to bug you.
Yeah, I'm still here. Go ahead, David.
Oh, sorry, I had a
Oh, so it looks like you generated a report. Yeah, I'm not exactly sure how to address this at the moment because it's a tricky thing because MAP is trying to expect an MPI code, but there is no MPI init to attach to. And you have to use AP run in order to get it to launch on the compute node. I'll have to look into this, but I don't have the answer off the top of my head.
That's okay. I'll try recompiling it as a fake MPI code and see what happens. So just out of curiosity, on an ARM system, we recommend using ARM clang over the GNU compilers, for example.
So we're going to say try both and then use whatever works better for you in that case. Because in practice, we found that sometimes ARM compiler works better and sometimes the GNU compiler works better.
Okay, cool. Thanks.
Yep. Sure.
So, Ryan, can you hear my audio? I wondered if there was a problem with my audio. I don't know.
Yeah, I can hear you now. Yeah. So.
I can't hear you, but maybe you're not. Oh, I can't hear you. Is it a problem? I might just have my speaker turned off. That might be the issue.
Oh. Can you hear me now?
No, it seems to be
Hello?
working. Is there something wrong with your audio, Ryan, or is it my? Because somebody else, could you speak, Paul, or somebody, just to check?
Can you hear me, David?
Okay, the problem's at my end. Problem's
Yeah, I
at
can
my
hear you.
end. Okay, sorry. Again, it's my stupid Bluetooth. Hi, Ryan. Can you try again? Sorry about that. I had a problem with my
Yeah,
speaker.
yeah. Can you
Sorry
hear me?
about that. I apologies. So my question was, I'll share the report. No, that's the wrong one, isn't it? So it says it's MPI bound, which is true, but it's only because it's very badly written that this is all a barrier, because there's an if rank equals 0, do the IO, else do nothing. Is there any way to start the performance report, to turn it off, to start it, on and off? Is there some pragma to turn it on and off in the code, or do you have to profile the entire code?
I know there is for map. Let me check perf report real quick. So if you do perf report -- help, let's see.
Because I only do a few iterations here to get a manageable run, but of course the IO is always the same, so the IO is huge.
So it doesn't look like there is an option for that, but if you do a map, so if I did map -- help, there's a start after option that you can do. So you can pass in, you can say,
Okay.
don't profile until after 1 minute has passed, and the same thing with
Okay.
stop after. Like if you don't want to
Okay,
profile
so
to the
time.
end.
Okay.
Yeah.
Okay.
So unfortunately, that option is not for perf report, but it is available in map.
Okay, I'll do a map run then.
So what you can do is you can do map, do start after, say, 15 seconds, 45 seconds, whatever you want, and it'll generate a map file. And then you can, on top of that, run performance reports on that map file to generate your HTML performance report.
Okay. Fine, I understand. Okay, yeah, I've got you. I'll just do the default though for the moment. So you run. It's just map minus profile. Okay. So it is interesting though. So the OpenMP, I don't know if it's getting there isn't any OpenMP turned on in this code, but I guess it's sort of counting the serial. Oh, actually, that's not true. The Cray compiler turns on OpenMP by default. Could that be why it's confusing? Why it's confused? Because there isn't any OpenMP. Well, that's interesting.
You can see like the peak process memory usage was 12 gigabytes compared to the average of 343 megs.
Bank 0 doing its huge allocate. I think the OpenMP is confused, but I think that's because the Cray compiler turns on OpenMP by default. So probably it's correct. It was probably the whole program was running in an OpenMP region with one thread. I think that's maybe why that metric's slightly confusing. If I actually turn it off, it may. If I explicitly turn it off, it may. So this is X forwarding from Archer, so it may be a bit clunky because. Okay. It's interesting. So could you, something I didn't understand is MAP seems to do dynamic, it seems to do sort of automated sampling rate. You know, it seems to decide how quick. Is that true, or?
Yes, it adapts to however long your program runs.
So does it have some, because of course it doesn't know at the start how long it's going to run for. Does it have some exponential? How to do that? It's quite, or does it throw them away as it goes along, or?
I don't know the exact details, but every time you go over, say, 2,000 samples, it'll adjust it and it'll do some type of smart averaging. That way you don't lose information.
Right. Okay. That's quite nice not having to guess that. So you can see this is the there's this huge serial I/O phase at the start, which is why it's all in blue. That's all MPI because everyone else is waiting in a barrier, I guess, or a broadcast. And then there's the calculation phase, which is still MPI dominated because it doesn't scale very well. And then, I mean, Paul's shown me reports like this before. Paul's generated reports on my code before. I have to say I've not done it myself. So there was an issue that it wasn't able to run with the new Fortran 2008 MPI interface. I know that the Scholastica people had the same issue because the MPI overloading of MPI init goes wrong or is harder or something. I don't know if that's I don't know if there's some way to fix that, but
Just to say, faith in my program as an MPI program has worked with MAP. So thank you very much for all the help.
Say that again, Paul?
Yeah.
By putting an MPI init and an MPI finalize into my program, that's successfully run with MAP now. So that's great.
Ah, okay, right. So yeah, the spurious reporting of OpenMP was fixed by disabling it. The Cray compiler turns on OpenMP by default. That was the issue.
Okay.
But you're saying I can now do a no. I could do a map report. Or I was going to say how long do I know, but how long is that? That's 30 seconds, say. Okay.
So
So
apart
what
from
was the syntax, Ryan? Was it minus after?
Start after, start dash after.
Oh, it's in seconds. Okay. Okay. I'll stop sharing.
Okay, for the other participants, are there any questions, or is everyone able to generate a performance report or a map profile, or do you have need any assistance?
A map file from a minus after run. How do I run the performance report on the? Do I just do?
Okay, just perf report and then the path to the map.map file.
Right, and I can run that just serially, can I, or do I need to?
Yes. Yeah, you don't need a node. It's not done in parallel. It's going to be fairly quick.
Okay. Right. It's not quite finished the run yet, but it's finished soon. So you're in Tennessee. You're still on Eastern time, are you?
Yes, I am.
I just looked. That feels like it's. I don't know. Maybe it's okay. It's further east than I thought. Okay, fine. I guess the US is a big place.
It's 4 times, more than 4.
So I just, it's a long way. Seems a long way from the East Coast, but yeah, it's not that far. It's not a huge. We had one of our MSc students who actually went to work at Oak Ridge, who started off doing tools development. Heike Yagoda. She started off in Dresden. I think she did some work on VAMP here in the early days, and then now works as a scientist, as a programmer at the Oak Ridge Lab, but the national lab.
Heike hosted the workshop that we did in Tennessee last year.
Oh, did she? Oh, okay, right. Yeah, she did our MSc quite a long time ago, 10 or 12 years ago, but she was very good. She did some fantastic diagrams showing how the all-to-all communications work in 3D fast Fourier transforms. I copied. I copy them quite a lot. They were these really good diagrams. So she's still at Oak Ridge then, is she? I knew she was there a few years ago, but
She's at the University of Tennessee.
oh, she's okay. So I don't understand the distinction. Sorry. Okay, fine.
Which is in Knoxville.
In Knoxville, sorry, it's Knoxville. I'm getting that. I'm getting my term. But National Lab is Knoxville as well, isn't it?
It's Oak Ridge, but
Or
it's
is it not?
Yeah.
relatively close.
Yeah, they're right
Okay,
next door.
Fine.
Yeah.
Fine.
So we had ARM at the workshop in Knoxville. This was presented by Nick Forrington. Were any of the others, any of the rest of you there as well?
No, it was just him. And he's actually in Warwick now, but he used to be the Oak Ridge representative for ARM.
Yeah. I think there was also someone who joined him, at least for part of the workshop, but I didn't get a name with this associate.
Might have been John Linford.
I know John Linford. It definitely wasn't him, but
Nope.
it may have been someone else from the lab rather than someone from ARM.
I see. Okay.
Yeah, Nick is working with me, keeping really busy.
Okay, so that actually I'll share my. That was very interesting. Thanks for that hint, because that was really. If I can share my screen, I get. No, sorry. So this was the original report, which had a lot of huge amount of serial I/O. Yeah, but when I did that after, I got So now it's 0 I/O. So that's really good. That's but it still says it's a lot in MPI, which is correct. Effective process point-to-point rate. Yes, Paul. I think people can speak. I think they're enabled. That's meant to be the way it's set up. Oh, sorry, that was a private message, Paul. Sorry, Paul was just asking if non-moderators can speak. Yeah. So that's.
Yeah, that's okay. I was just conscious that we're asking a lot of questions in case other people know where they can talk.
So that looks very low, but it could be because my messages are all very small. They could be latency dominated. That is interesting. So Paul, did you? I get very little vector time. Did you try the map tool on a code which ought to vectorize to see if it picked it up? I was always quite disappointed by the vector. It was because it's.
Yes. So the other program I've been using it with, it shows it's achieving about 5% floating point vector utilization. So disappointingly low, but it is reporting it here.
Right. I could maybe try a code.
Sorry, this is with the map. I wasn't actually aware of this performance report before today.
Ah, with map, fine. Okay, right. I'm going to have to. Don't know if I'm going to have time to run this. Oh, am I sharing? No. I'd like to profile. Oh, I don't have a chance to do it. What I planned to do, Brian, was to correlate that with the same Scholastica, the information I got from Scholastica on the same program to see if how they sort of.
Sounds like a great thing to test. Yes.
I mean, Scholastica has a lot more per process information, doesn't it? Doesn't focus much on the aggregate.
Yes, I mean, we give you the breakdown per process, but we won't go into as much detail into the vectorization or the things that's happening inside a process, inside a core.
Something I would. Because we're considering, well, I need to speak to the course organizer. We have on our introductory HPC MSc course, the online version, we have a tools section, and we currently used the Cray tools because they're so easy to use on the Cray, but of course they're not portable, so we need to port that exercise to a portable tool set, and we were thinking Scholastica maybe we'd try to find. We just give students a code which they're supposed to run a small. They're basically supposed to do a speed up curve of a small and a large run to show that it doesn't scale well for small problem sizes, but it scales well for big problem sizes. But then also to do a profile to verify that, to show that the time spent in MPI was more and was fractionally. That would be. Do you have those aggregate type stats in Scholastica, or is it really quite easy to see it spent? The kind of the sort of equivalent of the performance report, or would it be per routine that it would say in Scholastica?
We give you a breakdown per call path, or you can also get it per routine. That's possible as well. Right.
Okay, so this would show up as time in MPI. So you can see that you were spending a lot of time in MPI send receive quite easily, for example. That would be the signature for this code.
But you would also get the context of where this send receive was called from, which call path it was coming from.
Oh, that's nice. Okay, right. Okay, that would not only would they be able to say it was taken, they would be able to say, and it is in the Halo swap routine that we expect. Because that would be nice actually. Fine.
But you should have the Cray tools on the Archer 2 as well.
Yeah, but the students are going to be using Cirrus.
Okay.
I think Archer 2 is going to be. Archer is not available early enough to put this year's intake onto it, so they'll be using our. They'll be using the Cirrus, which is just a sort of generic Intel InfiniBand cluster. So we need to. That was one of the reasons I was keen to look at the tools. We need to transition that exercise to that.
Yeah, the Cray tools are nice, but they're only on Cray systems, so that's
The nice thing
definitely a
with the
constraint.
Cray ones is they're sort of shrink wrapped, so you just say, you know, they're all integrated because they're already targeting. You know, just say it gives you a reasonable amount of useful information with very little effort because that's because it's tightly coupled into their whole tool suite. So it's not, but we could. It wouldn't be hard to give people a recipe for Scholastica, for example. And you support, I'm sure you do. Sorry, I wasn't able to attend quite a few of the talks, but you have Windows, the cube and things all run on. Your visualizing tools they're available across platform, are they?
Yes, the GUI is on Windows, on Mac OS, on Linux, but the measurements are only on Linux systems.
Yeah, I appreciate that, but I mean, people could take it offline and they could do once they could do on a Windows machine, they could equally navigate spaces and such like as easy as they could on a Mac or a Linux box.
Yes.
Yeah, that's useful.
We're working on this client-server business, so you can connect to the remote system, but at the moment that's still in development. Of course, you can use SSHFS as was demonstrated earlier. Just remotely mount the remote file system where the measurement is done. Otherwise, you just have to copy the file, SCP the file to your laptop.
Yeah, that's not.
It's tedious, but it's doable.
Yeah, it's not. It's not such a big deal. I don't have time to do that. I'll do that test offline.
Yeah.
Paul, how big have you run MAP Archer? We have quite a big license, don't we?
Yeah, you got 32,000 MPI ranks, so quite a big.
Okay,
license.
yeah. That's good. Yes, I'm not involved in the. Sorry.
I was going to say we have about 6 minutes left, so I'm just wondering, should we give it another minute and then start summarizing?
Yeah, that would be useful. As I said, I appreciate it's quite late in the day for a lot of people. It's been long, but yes, it'd be worth doing that. I said the reservation runs out at half. That's why I can't do my test. The reservation is going to run out in 5 minutes, so I'll just do it on my own account later on.
That explains this. I tried to run something, I think about 5:45 yesterday. Just got stuck in the queue allocation. I thought maybe it just ran out yesterday and started again. I think about 7:30 this morning.
We have, if you submit to a reservation which is in the future, it will queue until the reservation comes live. If you submit to a reservation which was in the past, it will say no such reservation. So I think you probably submitted to today's reservation yesterday, in which case it would have queued up till it came live, which would have been early this morning.
Yeah, that's exactly what happened. I was trying to run some things for the demo, but it was okay. I managed to get enough done this morning.
Yeah, it does. The queues the reservations behave in a slightly strange way. You'd thought at least give you a warning that the reservation wasn't currently active, but it doesn't. It just I mean, I don't know how it's going to work in Slurm because there's quite a lot of I don't know. I've not really used Slurm much before, but PBS is PBS on Archer is a bit clunky, I have to say, but it is very old. Archer's 6-7 years old now. It's really quite
Cool. Well, just to summarize then, so I hope found map and performance report. Kind of the whole point is to make it easy to run. So you have your code, and you just append the port, or the map before it. Then press the echo. It sounds like mute. Someone on mute. Okay, yeah, yeah. So I found it quite easy to use. So you literally just put performance reports or map before you run your AP run command, and then it spits out either map report or a performance report, or you can run map with it. So the point of it really is just to give some judgment and some insights into what you're busy running, and you find, okay, there's something in this area, I'll try something, and you make the change and confirm it. So those are all the positives with what you get out of it. And the good thing is, while it supports AR64, it's not just an ARM tool, supports PowerPC and x86 architectures as well, and a range of different compilers and job schedulers and MPI implementations. And apart from profiling, we also have of GDT, which is the debugger. You're able to debug some of your parallel codes. And if you have any problems with any of our tools, you can always contact us on support-hpc-software@arm.com, or just go to developer.arm.com/support, and there should be quite a lot of information there on how to use the tools and what we support. And yeah, that's pretty much it. So I hope it was useful, you guys.
No, I find it very useful. So
Yeah.
I hadn't used the performance reports before. I'd seen them presented at your stand at Supercomputing a few times, but I'd never actually run them myself. So I hadn't realized it was quite so straightforward. I thought there was more. I thought there was more involved to generating it.
Yeah, so we try to make it as simple as possible. Because with
separately from map, or is it part of the map? Is performance report map the same?
So map and performance report, you're saying, are they the same thing?
Yeah, they license separate.
So as part of our latest ones, we package them into the same product. But I think you need licenses for them separately. But they package it into the same product. You need a separate license for them. So either license performance reports, or you license map and DDT.
Right. Okay. So they are fine. Okay.
Cool. Well, unless there's any questions, I think that's us finished. Unless you have anything to add, Ryan.
Yeah, I'd like to present a short review of the workshop. It won't be long. It will be like 5 or 10 minutes.
That's fine.
Okay, let's go. Okay, I will just let it answer the question if you want. Or Ryan.
Ryan, did you see the chat question from here? I don't know if you got the chat open.
Sorry, is that a question to me?
Well, just generally, teaching license for ARM4. He was asking, do you know if that available or not?
I know that we do offer educational discounts, but that is a question for our sales team. And if you're interested, I can get you in contact with one of the salespeople. But that's not something that I can address directly.
Okay. Thank you. So If that's okay, I will present a short review of this workshop. So, never get it. Yeah, so you have now, I hope, a better idea for the tools that you have been presented. Each of them with their main area of expertise. So the tools are complementary and provide information on different parts of the performance engineering process, be it on the computation or processor side, or communication and synchronization and then parallelization issues. Tools also have different trade-offs, so you can have some more or less specialized tools, some very simple tools performing a single task, but quite extensively, or other tools that may be more complex but more powerful and offer more options. So now with this, we hope that you get a better idea of which tool to use for which issue. The idea, of course, is that it will depend on the system you are using and the programming language or paradigm you are using. Another point that's rather important, that's whether you actually like using this tool. That's a problematic that you can also have with programming language or text editors and the like. And of course, you need to have an idea of the type of issue you suspect, or the question for which you want an answer. So for all that, it's useful to have a knowledge of the different types of tools that exist and the type of question that can help you answer. So if you want to proceed, the idea is first to make sure that the application is running correctly. So that's where debuggers and correctness checking tools will allow you to check that your application is actually executing and that the results that you are generating are accurate and consistent from one execution to another. So we didn't have any presentation of correctness checking tools, but there is ARM-DDT, for instance, that's a powerful parallel debugger that can help in this stage. Next, you will want to get an overview of what's happening inside the program. So for that, you can use parallel profilers, and you have seen a lot of them during this workshop in the Scorpy tool suite or map today, and Macau and Tau. And you may also want to check exactly the repartition between threads and how messages are being exchanged inside the application. After that, you may want to check exactly what's going on specifically inside the parallelization. So there are two different types of scaling. Weak scaling is where you do not you have a fixed computation, and increasing the number of threads will simply allow you to process more data. So in weak scaling, normally you don't have a lot of communication, since each thread will perform its own work on its side. And what you expect, you don't expect a speed up in weak scaling. You simply expect to be able to process more information. Conversely, strong scaling is where you want to reduce the time by increasing the number of threads, and this usually implies increased communications. So more data and more the load balancing issues. So this is where you will want to investigate why threads are waiting for one another, and why are we, whether we are actually wasting time because of load imbalance or time spent in communication. So that's where you can use tools. During this workshop, you have seen, for instance, Scala and the BSC tools that can help you during this task. And there is also a Vampire from which you had a short introductions. And finally, of course, we want to make sure that computation is performed correctly. So we want to make sure that the application is using the correct version of optimization library, that the compiler has correctly done its job. So most of the time the compiler is to best ally, but you need to know how to properly help it optimizing your code, and you may want to make sure that the hardware capabilities of the machine are being used at their full extension. So for that type of question, you can use, for instance, Macao, and there are some specialized tools that can help you in this, and process reports. So by now, you're probably getting familiar with this diagram when you can see where each tool integrate, and you have seen during this workshop at which point of the performance engineering process you can use which tool, whether it be to debug, or checking exactly what's going on inside the application, or checking the way parallelization is implemented, and whether computation actually is correctly implemented. So now we hope you have found this workshop interesting, and we expect some feedback. So you will receive links for a PRACE feedback form. And we thank you if you take the time for completing it. You will also receive a link for an evaluation of the VI-HPS workshop and the tools that were represented during the workshop. So please also fill this form. It's quite important to us to be able to find exactly where we can improve either the workshop and the presentation of the tools themselves. So this is also particularly important. This is the first online workshop that we're organizing, so we value your feedback. Just one point about these online forms. You are requested an email address that is for consistency checks. If you want your form to be anonymous, you can simply not fill out your name. The email addresses will be filtered out anyway from the results. And if you have any question about the tools, you can contact the tool developers directly. We always value input and feedback. And some future information, you can refer to the VI-HPS website for news about future events and tools, and collect training materials and additional information tools and the activities of the VI-HPS. So thank you for attention. Thank you for attending this workshop, and also thank you to David and all the people at EPCC for organizing this.
Yes, I'd like to say thanks, Ed. So I mean, the original plan had been to run this on Archer 2, but we decided that given the portable nature of most of the tools, it was worth doing it now in Archer. We will, I mean, VI-HPS have given us a run of this workshop every year for the past several years, and we would be hoping that we could get a run sometime in 2021 when we'll have a lot of users who have just ported codes to Archer 2 who will be actually looking at the performance and stuff. So hopefully a face-to-face course. We'll have to discuss it with you if that's possible. That's what we would like, if possible. But the timescale will depend on COVID and Archer 2. But it would be really nice to get people running their tools early on when they've just ported to Archer 2, so they can spot problems and such like early on. So thanks everyone. It's been a not only we're not using the machine that we thought we were using, we're doing it online, which we've not done before. But I think the technology has worked remarkably well. I think, given all the potential issues, we've got people, presenting from the US, the West Coast of the US yesterday, with no problem. So I'd like to thank everyone for all their help and all the effort they've put in. And these lectures are recorded for later use and edited. And so hopefully even if people weren't able to be at the workshop, we'll point people at these materials and they'll be there for reference. So just like to thank everyone, and